Hi class, let's look at number 2. So David has available 400 a rectangular area. Let's express the area A of the rectangle as a function of the width W of the rectangle, and then we'll find for what value of W is the largest area, and then what is that maximum area. So to begin, let's just draw our rectangle. And we have length, and width. And David has available 400 yards of fencing. So this is telling us fencing is referring to perimeter. I also checked the units. Yards, it's just not yard squares, not area. So the 400 is equal to P. So P equals 400. And David wants to enclose a rectangular area. So the formula for the perimeter of a rectangle is P equals 2 times the quantity L plus W. So again, with perimeter, you're just gonna add up all the sides. You might have traditionally looked at it as 2L plus 2W. I sometimes find it helpful to factor out the 2, because when I plug in my 400 for P, I want to immediately divide both sides by 2, so that I'm going to have the equation 200 equals L plus W. Alright, so for part A, we want to express the area of the rectangle as a function of the width of the rectangle. Let's go over here. We know A equals length times width. And so one thing that I find helpful too when I'm looking at these problems is we want it to be a function of W. So when I look at this, I don't want there to be an L. I want everything to be in terms of W. So then I'm going to go back over to my perimeter, and I'm like, I don't want L. But if I look at L here and solve for L, L will be in terms of W. So then everything in my area will be in terms of W. So what I want to do is solve for L. So subtract, well, I'm going to subtract W to both sides. Yep. So then L will equal 200 minus W, and plugging this into my area formula. So we'll have 200 minus W times W. And this is my answer for part A. And you can also distribute the W if you'd like, and I'm going to put the exponents in decreasing order. And so this is our function for the area in terms of W. Now, for part B, we want to know for what value of W is the largest area. And for part C, we want to know what is the maximum area. And so when we look at our equation for the area, it's a quadratic. We also know that the parabola is reflected over the x-axis or concave down, and so that this parabola has a maximum. And so then that means, well, where does the maximum occur on a parabola? It occurs at the vertex. So we want to find the vertex for this parabola. And before we kind of go and do all that, at this point, in calculus, you would want to be able to do the part up to part A. And then the cool thing in calculus that you'll learn how to do is, instead of finding the vertex of your quadratic, you can do other things to determine that maximum. And the cool thing about this is that the reason why we need calculus is that if we had a function that wasn't quadratic, like maybe it was cubic or a degree 4 polynomial, then how do you find the maximum there? I mean, of course we can use graphing technology, but we're going to need other ways to do that, and so calculus helps us determine those maximum values or minimum values. So for part B and kind of C, we're interested in looking for the vertex. So let's just put B and C. We want to find the vertex. So here, for part B then, we want to find the x-coordinate of the vertex. In this case, it's the w-coordinate. So we know w will equal negative b over 2a, which will equal negative 200 divided by 2 times negative 1. The negative cancels, and then 2 into 200 is going to be 100. So the width should be 100 yards. Alright, for part C, what is the maximum area? So then here we want to find what's the area if the width is 100. If the width is 100, well, you can kind of use a whole bunch of tools to find the length. You can go 200 minus 100 here to get the length, or you can just plug in your width of 100 here and find the area. I don't necessarily like this one too much because it's a little bit more cumbersome to do the work. So always kind of play with your equations and use the one that's a little bit easier to evaluate. So essentially though, we're going to have A of 100 will equal, let's just write this out, 200 minus 100 times 100. And so that's going to give us 100 times 100, or 10,000. And we're talking about the area now, and so it's going to be units squared, so yards squared. Alright, so hopefully you found this helpful, and I will see you in the next video.